In this section, we'll move to the present day and talk about current Wi-Fi security methods. Let's first talk about WPA3 Personal. Now, WPA3 Personal is the latest and improved version of the security certification standard developed by the Wi-Fi Alliance, and it's a major improvement over its predecessor, WPA2, which has been in use since 2004. Now, WPA3 is designed to improve security for Wi-Fi by providing increased protection of data that moves across personal and enterprise Wi-Fi networks. And WPA3 has several updates that include better protection for simple passwords, encryption for personal and open networks, and more secure encryption for enterprise-based networks. Now, WPA3 Personal enhances Wi-Fi security for home users and environments where 802.1x is not an option. Now, passphrase is still used to connect. However, the SAE protocol exchange protects the passphrase from brute force dictionary attacks. And WPA3 Personal defines two modes of operation, and that's WPA3 Personal Only and WPA3 Personal Transition. Now, Personal Only replaces WPA2 PSK authentication and requires the use of SAE authentication. SAE stands for Simultaneous Authentication of Equals, and SAE is a secure key establishment protocol that enables users to authenticate to a Wi-Fi network without sharing a common pre-shared password. Instead, SAE uses a password-based key exchange, which protects against offline dictionary and brute force attacks, and ensures that even if an attacker intercepts the authentication process, they can't easily determine the password. So during SAE authentication, the client and AP engage in a secure negotiation to establish a shared key. And this key is used to encrypt the wireless communication, providing confidentiality and protection. And SAE also provides forward secrecy, meaning that if the shared secret is compromised in the future, previous communications remain secure. WPA3 Personal Transition allows for backwards compatibility with WPA2 Personal, enabling WPA2 Personal clients to connect to the same SSID as WPA3 Personal clients. And key features of WPA3 include management frame protection, which protects unicast and broadcast management frames and encrypts unicast management frames, and simultaneous authentication of equals. It's also important to note that WPA3 is mandatory for Wi-Fi 6E. During the actual authentication, the exchange begins with the client sending a commit message that includes a random element, a scalar, and an element. The AP responds with a commit message that includes its own random element and scalar. The client and the AP then use these values to derive a shared secret key. A random element refers to a randomly generated value, typically a large number, that serves as an input in the key derivation process, and it adds an element of unpredictability to the authentication process, making it more secure against potential attacks. The scalar acts as another piece of information used in deriving the shared secret key. It combines the random element to contribute to the generation of a secure and unique key for the client and AP. And next, the client sends a confirm message that includes the information derived from the commit messages and the shared secret key. The AP verifies the information and responds with its own confirm message that includes information derived from the same values and the shared secret key. And then finally, the four-way handshake takes place to establish the encryption keys and the integrity protection keys. WPA3 Enterprise is an advanced and robust security protocol specifically designed for enterprise-grade Wi-Fi networks. It offers a powerful combination of username password authentication and 802.1x authentication, and that provides a strong defense against potential security threats. And by incorporating both methods, it ensures that only authorized users with valid credentials can connect to the network. And one of the standout features of WPA3 Enterprise is the optional 192-bit encryption, which takes security to the next level. And this heightened encryption ensures that data transmitted over the network remains well protected from potential eavesdropping. And WPA3 Enterprise operates in 3 distinct modes to cater to various network setups and migration scenarios. And these modes include WPA3 Enterprise Only, WPA3 Enterprise Transition, and WPA3 Enterprise 192-bit. And each mode is tailored to address specific security requirements, ensuring seamless integration and a smooth transition for organizations upgrading from older security standards. And to further strengthen security in WPA3 Enterprise Only mode, the use of management frame protection is mandatory for both access point and client. And MFP guards against various attacks, adding an extra layer of security to protect the network from potential disruptions. And WPA3 Enterprise is especially suited for enterprises, financial institutions, government agencies, and other critical sectors that handle sensitive and confidential data. WPA3 Enterprise builds upon the foundation of WPA2 Enterprise, with the additional requirement of using protected management frames on all WPA3 connections. And by default, WPA3 uses 128-bit encryption, but it also introduces an optionally configurable 192-bit cryptographic strength encryption, which gives additional protection to any network transmitting sensitive data. The EAP exchange is otherwise the same. So let's talk about Enhanced Open. Now, Enhanced Open solves the security issues involved in completely open Wi-Fi networks. The experience for the user is the same because there's no need to enter a password or passphrase when joining the network. Enhanced Open uses opportunistic wireless encryption protocol that establishes unique individual encryption that protects the session between user and AP. And when a client device wants to connect to an OWE-enabled AP, the OWE exchange takes place, and it starts with the client sending an association request to the AP. In response, the AP includes an OWE information element in the association response frame, providing the necessary parameters for the exchange and indicating support for OWE encryption. The OWE exchange continues with the Diffie-Hellman key exchange between client and AP, and this cryptographic process enables them to establish a shared secret, which will be used to derive encryption keys for securing the communication. And once the Diffie-Hellman key exchange is completed, the AP sends a confirm frame to the client containing the confirmation code generated from the shared secret. ECDH in the chart stands for elliptic curve Diffie-Hellman. Now, to ensure the authenticity of the AP and the success of the key exchange, the client independently computes the confirmation code using the shared key and verifies it against the received code. And if the code matches, it confirms that the AP is legitimate and the key exchange was successful. And following the OWE exchange, the process concludes with a four-way handshake. And with the four-way handshake completed, the client and AP can establish an encrypted communication channel using derived encryption keys.